So welcome to today's amplitude modulation class, and so now we're at the week 3, and from last lecture we talked about what is the channel degradation, the noise interference, the distortion, the signal to noise ratio, and EM spectrum. But from that we also need the need for the modulation and all the types of modulation. So now we would like in the transmission of information, we have the carrier generated, that's the transmitter. The carrier modulated with the information to be analog or digital. As the receiver, the signal modulation can be detected and modulated. So there are some bandpass modulation, for example, the modulation of the modulation of the analog signal, the digital signal, the modulation of the AM amplitude modulation, the double-sided modulation, the super-sided, which will be explained later. So the amplitude modulation is called AM, which means we have the modulation of the index, the spectrum of AM, and in terms of the modulation, there are many things to be considered. For example, look at this word cloud. We have the carrier, the modulation, the sideband, the signal spectrum, the amplitude, the envelope double, upper DSB, something like that. And the amplitude modulation is the process of changing the amplitude of a higher frequency carrier signal proportional with the instantaneous value of the message. It is used as the commercial broadcasting of both the audio and the video signal, and is also used for two-way mobile communication, such as citizen band radio. There are mainly three forms of amplitude modulation, which is called double-sided large carrier, or AM, or double-sided super-pressed carrier, or simply DSB. DSB is double-sided super-pressed, double-sided super-pressed, and the single sidebanded signal, which is SSB, single-sided signal, which is the SSB, and the vertical. So let's firstly look at what is vertical mean. Vertical means the vertical means Invested climbed to enhance the fish to the cloud of the land. He feels vertical. So vertical means forming a very small remnant of something that is once much larger, more I think it's something related to digest. Oh, I see. Vertical. Okay. And then we would like to see the basic amplitude modulation. In this case, the sound signal to a microphone, the carrier wave generated at the transmitter. We also have the electronic image of source of a formed microphone, the amplitude modulated carrier, the AM or radio station that is transmitted. So the amplitude modulation is that for example, we have the information signal as the information signal, which is the sound signal to the microphone, and then we would like to give a carrier which is called a transmitter, and then the modulated carrier form, which is the AM radio signal as the transmitted. We can modulate together. So how do we modulate it? Like we use the envelope. We use the signal to envelope the signal. Okay. And for the modulating signal, we have the this is the modulating signal. This is the carrier signal. We have the modulated signal. So now let's look at what is within the amplitude modulation. For example, that this is a baseband signal, and this is a carrier signal, and we combine to be a bandpass signal, which is a modulated one. So how do we do that? It's let's see, this is the original signal. This is the carrier signal, and we can use this formula to calculate this. So how do we do that? So the first thing is that we must times two things together, times two cosine together, because we need the frequency to be shifted, right? We need the frequency to be shifted. So the reason why we want that is that we want a higher frequency, right? Okay. So we must times the original signal with a constant k. Constant k is going to change how much would you like to change the signal, and times with the carrier signal. That is obvious. And apart from that, I also need the cosine 2 pi fc t times the AC. The reason why we need that, why we need a 1 here, because we want them. We do not want them to be related to 0, because that will mess up the signal. Therefore, I must plus 1 together with the original signal, and times with the cosine 2 pi fc with the AC. And then we would like to look at the modulation index, which is called the Ka. Is also called modulation sensitivity. So the thing is that the modulation of a sinoid carrier form AC cosine 2 pi fct by a baseband signal MT with a maximum amplitude of 1 produces a signal ST, which may be displayed as follows. So the message MT is there, and the AM signal is there. The original message is only the envelope of the ST. If the Km less than T, such that 1 plus Km T is positive. So we must want Kmt less than 1. The frequency of the carrier is much greater than the baseband. The frequency of carrier is much greater than the baseband. That's very obvious. And the modulation index is a measurable constant which the carrier voltage is varied by the intelligent signal, as known as the modulation index and the modulation factor, or the depth of modulation, or the percentage of modulation, and it is simplified by m. The m is less or greater than, if the m equals to 1 means it's no modulation, if m equals to 1 means it's 100 modulation, if m is larger than 1 it's over modulation. So the amplitude of the modulated carrier, which means we have the A min, A max. So the question is how do we calculate from here? So the modulation index is calculated by A max minus A min divided by A max plus A min. So let's see, A max is 5 minus A min is 5 minus 2 plus 5 plus 2 is 3 divided by 7. So this is this one. And then what if it's over modulated? Then the Ka is too large. So 1 plus Ka MT might be negative, leading to overmodulated. Why is 1 plus KAMT? Why is 1 plus KAMT matters? So let's look at 1 plus KAMT. 1 plus KAM, which means that 1 plus KAM can be less than 0. So I mean, if this is 1, so this can be less than 0. Since it's less than 1, it's also likely to be less than 0. What if less than 0, the original signal is missing? So that is not good. So that is the thing. So we don't want the Km to be too large. We don't want the K 1 plus KAMT to be less than 0. Therefore, we want the what if Ka is too large? Since the cosine can be negative and not positive, therefore K cannot 1 plus Ka times MT times the cosine in MT. I think MT is the cosine, right? MT is this one. MT is this one. Can be less than 0. That's can be equal to 0. That's obvious. And so the envelope of the modulated is distorted by the amplitude sign changes that occurs whenever 1 plus KMT less than 0. That's obvious, because the reason why we need this one is we do not want this to be less than 0, which means that we want the Ka to be larger, to be less than 1. Right? We want the Ka to be less than 1. This M is equals to so Ka is M. Ka is M, which means that K is less than 1. That's obvious. Okay. So let's continue look at the so this is overmodulated signal, and this is the spectrum of a tone AM, which means that remember that cosine A times cosine B is equal to half of cosine A plus B plus half of cosine A minus B. Thus we write down amplified modulated as AC cosine omega ct plus half of AC m cosine omega c plus omega mt plus half of AC m times cosine omega c minus omega t. So we have the upper sideband at the omega c plus m. The carrier at omega c, the lower band is the omega c minus omega m. So in this case, this is the upper sideband, and this is the lower sideband. However, in this case, what if it's negative part? This is the upper sideband, and this is the lower sideband. So there are some interactive app to demonstrate that. You can download and play with it. And the message frequency is 5 Hz. What is the frequency? Look at this. So what in one, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, we have 10 times higher than this one. The carrier frequency is 10 times higher than the message frequency, so it's 5 times 10, which means it's 50 kHz. So let's now we have continue what is the double-sided band large carrier signal, which is called AM signal. Generally, we'll cover about that. So next week we're going to talk about demodulation.